Look, we all know modern AI is eating the world right now, but it's also absolutely devouring our power grids. I mean, we are facing a massive energy and computational logic crisis. But what if the fix doesn't come from a bigger data center, but from a completely unexpected place, like decentralized finance? Welcome to The Explainer. Today we're going deep into the invisible math that actually holds our digital world together. We're going to uncover a microscopic flaw at the very foundation of modern computing and see how this revolutionary one-bit framework is completely rewriting the rules of artificial intelligence. Let's get into it.
To really wrap our heads around this revolution, we've got to start with a pretty fundamental question. When you talk to an AI, it really feels like it understands you, right? But that feeling, that's what researchers call the grand computational illusion. It totally shatters our basic assumption that machines actually comprehend the meaning of our words. Because the truth is, beneath the surface, there's zero understanding. They are literally just doing probabilistic physics. It's like they're rolling millions of microscopic dice at lightning speed just to guess the next best word. In doing all that mathematical guessing, it burns a staggering amount of energy.
So, here is our roadmap for this explainer, to trace the clues from these tiny silicon flaws to an unexpected Web3 solution. We'll hit the grand computational illusion, hitting the Trig Wall, the polar AMM bypass, Sida normalization, and GRT, and wrap up with bit-perfect one-bit LLMs.
All right, Section 1, the grand computational illusion. We have to start our detective story by looking at the original sin of computer math, way down at the very bottom of the hardware stack. So, to process massive language models, AI chips rely incredibly heavily on a component called the floating point unit. For our purposes, let's just call it the FPU gambler. It's designed to guess calculations really fast. But here is the fatal catch: floating point non-associativity. Since continuous numbers have infinite decimals, the computer literally doesn't have the memory to store them all. It's physically forced to chop the ends off to make them fit. Every single time it calculates, it rounds off these tiny bits, and this causes what's known as a wood chipper effect. Once those decimals are chopped off, you can never ever get the exact original number back. It's like trying to unblend a digital smoothie. The exact mathematical provenance of that data is just permanently destroyed. Now, to really grasp why this matters so much, we need to contrast the two entirely different brains inside your computer chip. On one side, we've got our messy, dart-throwing FPU gambler. Sure, it's fast and probabilistic, but it's built entirely on lossy approximations. On the other side, we have the ALU Surveyor, the arithmetic logic unit. The ALU deals strictly in undeniable cold hard mathematical truth. It only uses whole numbers, right? Integer arithmetic. In the ALU's world, 1 plus 1 is exactly 2, every single time, zero guesswork. But right now, traditional AI basically ignores the surveyor and relies almost entirely on the gambler.
Moving on to Section 2, hitting the Trig Wall. Let's see how this hardware flaw turns into a massive roadblock for modern AI. Think about how an AI tries to actually understand human language. It takes our fluid, continuous ideas and maps them onto these complex geometric graphs using curves and angles. We're talking heavy trigonometry, like cosine scoring. But computer hardware is fundamentally made of rigid, discrete squares, bits. When you force continuous curves into rigid squares, it creates absolutely devastating friction. You're forcing the FPU gambler to guess how to fit a round peg into a square hole. And the more complex the curve gets, the more the FPU has to guess. These approximation errors compound rapidly until they hit a critical failure line. Researchers literally call this hitting the Trig Wall.
And look, these aren't just invisible, abstract math problems. They translate into the very real, very public failures we see in AI all the time. When the FPU gambler rounds off too many decimals, the mathematical foundation literally just collapses. That is what causes fatal stack overflows, semantic collapse, and those unpredictable AI hallucinations everyone is always complaining about. The AI isn't just getting creative and making up facts. It is suffering from a compounding math error right down at the silicon level. Not to mention the insane waste of compute and energy just moving cache around, waiting for the processor to finish guessing the math.
Okay, Section 3, the polar AMM bypass. This brings us to a totally unexpected Trojan horse solution, emerging straight from the world of decentralized finance and automated market makers. Now, you might be wondering, why on earth are we looking at Web 3 to fix an AI problem? Well, because Web 3 developers hit this exact same wall, but honestly with far higher stakes. The Ethereum virtual machine fundamentally cannot perform floating point arithmetic or native trigonometric operations. Why? Because in a decentralized network, tens of thousands of computers must reach the exact same answer to maintain consensus.
If they used the guessing FPU gambler, the computers would disagree on those tiny chopped-off decimals, consensus would instantly break, and billions of dollars would literally just vanish. Poof. They absolutely had to find a way to do complex math using only whole exact numbers.
The breakthrough here came through the lens protocol evolution. They built an exact algebraic ring, completely shifting away from continuous Euclidean curves. When they hit their own limits with sine and cosine angles, their own trig wall, they made a massive leap. They replaced continuous angles with discrete rational Pell-Smith coordinates. Okay, to put it simply, instead of trying to draw smooth, continuous circles that force computers to guess, they mapped the math onto a strict pixelated grid where every single point is a verifiable whole number. They completely bypassed trigonometric guessing using exact on-chain algebra. It's brilliant.
Which leads us perfectly into Section 4, side-end normalization and GRT. So how do we actually take this exact, guess-free math from DeFi and use it to cure AI's hallucination problem?
It all starts with something called psi-A normalization. This is our ultimate weapon against the FPU gambler. Psi-A normalization anchors the entire coordinate system so that the variable A always equals 1. By doing this, we take those messy, curve-heavy geometric shapes and force them into perfectly straight, exact lines. Just think about the impact of that for a second. By turning curves into straight lines, you completely eliminate the need for complex, power-hungry trigonometry. And if there's no trigonometry, the FPU gambler is officially out of a job. The exact, reliable ALU steps up and takes over completely.
But wait, what about the decimals? If we aren't rounding them off, where do they go? That is where global remainder tracking, or GRT, comes in. GRT is a mechanism that natively tracks the exact mathematical leftovers. Think of it as a system that never, ever throws away the spare change. Instead of rounding off and deleting those tiny fractions, it uses discrete reciprocal shifts across a rational lattice. It basically just shifts the math along a grid so every tiny fraction is accounted for natively, guaranteeing 100% mathematical fidelity.
Let's just pause and synthesize this breakthrough because it's so elegantly simple. It's a three-step paradigm. First, you anchor the system to A equals 1 to straighten out the curves. Second, you swap out the messy trigonometry for discrete reciprocal shifts. And third, you natively track all the leftovers via GRT. This right here is the exact recipe to rebuild AI without a single guess. It officially unblends the digital smoothie and restores verifiable digital truth.
And finally, Section 5, Bit-Perfect 1-Bit LLMs. We've arrived at the staggering climax of this cross-disciplinary explainer. By uniting these DeFi concepts with AI, we achieve bit-perfect orientation inside the arithmetic logic unit. We've completely abandoned spatial approximation for absolute integer geometric rigor. What this means in plain English is that the AI is no longer floating around in some continuous space of probabilities. Because we are now using pure exact whole numbers, the successor operator functions as a direct computer language command. The AI just moves confidently from one absolute mathematical certainty to the exact next one. The contrast here is literally the paradigm shift of a generation. Legacy AI just keeps spinning its wheels, relying on FPU guessing, compounding errors, and risking fatal crashes while burning massive amounts of energy. The new 1-bit ALU framework, it relies on exact integer tracking. And because it uses exact math, it grants us deterministic hardware halting. That means the machine mathematically knows exactly when a problem is solved, and it stops instantly. This is the key that safely enables infinite context AI without ever drifting into those unverified hallucinations.
And the physical impact of this exactness, it's absolutely staggering. All that energy wasted by the FPU guessing and shunting memory back and forth, gone. By intercepting the prompt with this absolute digital truth, we achieve an incredible 74 times energy reduction. We're hitting an unprecedented 0.05 picojoule energy floor per operation. This isn't just a marginal little improvement. It completely rewrites the economics of running and scaling artificial intelligence globally.
There is a brilliant quote from the source material that summarizes this entire journey perfectly. We are quite literally tricking rocks into thinking with lightning to perfectly automate our imagination. Just let that breathe for a second. By bridging the strict consensus-driven math of DeFi with the architecture of neural networks, we have successfully built a semiotic bridge. We've eliminated the lossy, guessing FPU gambler and completely empowered the perfectly deterministic ALU surveyor. We finally actually have an AI brain that thinks with the undeniable precision of a calculator.
When the machine no longer has to guess, when AI is built on absolute mathematical truth instead of statistical approximations,
The ceiling for what we can build completely disappears. The semiotic bridge of absolute digital truth is officially constructed. So I'll leave you with this one final thought to chew on as we enter this completely new era of computing. What will you program it to do? Thanks so much for joining me on this explainer. Keep learning, keep exploring, and I'll catch you on the next one.